The question 1812, it says determine the velocity of the 50 kg cylinder after it has descended a distance of 2 meters. Initially, the system is at rest. The reel has a mass of 25 kg and a radius of gyration about its center of mass A. Ka is equal to 125 millimeter. So it has a pretty complicated shape, so that's why radius of gyration is given to us, and the radius of the reel is 75 millimeters. So we are given with the mass of the cylinder, mass of the reel, the distance the cylinder has descended, the radius of the reel, and the radius of gyration. So we use the principle of work and energy, in which the kinetic energy for state 1 plus the potential energy from state 1 to state 2 is equal to the kinetic energy of state 2. So we know that system is initially at rest, so T1 will be equal to 0. And for calculating the potential energy, we multiply the weight with the distance it has descended. So weight is 50 multiplied by 9.81 multiplied by 2, the distance which it has descended, so we get 981. And for T2, as it is a general plane motion, so we use the equation 1 by 2 multiplied by I, which is inertia, multiplied by the omega, which is the angular velocity, the square of it, plus 1 by 2 mass of the cylinder multiplied by its velocity square. So we know that the mass of the cylinder, but we don't know the velocity, so we keep the second part of equation as 1 by 2 multiplied by 50 multiplied by v square. Now we have to focus on 1 by 2 I omega square. This is for the real part. So we use a chart of shapes and we get that the equation of inertia for this shape is mr square, but we'll be using mk square because it is the radius of gyration, and we get the inertia after putting the values in is 25 over 64. We put it in back in the equation. We convert omega square into velocity over radius whole square, and we know the radius of the reel, so we put the radius over there, but we don't know the velocity, which we are finding. And then we further simplify that equation and we get 59.72 v square. This is for T2, and then we simply put in the values T1, which will be 0. We know that the summation of potential energy from state 1 to 2 is 981 is equal to 59.72 v square. We solve this thing and we get v is equal to 4.05 meters per second. This will be the velocity of the cylinder after it has descended 2 meters.